Unmanned machines will make the journey, gathering detailed information: size, shape, density, composition, internal structure, rotation, and gravity. This will inform us what to do next. There are several ideas on the drawing board. Here are 3 of them. Designed to target the asteroid for a controlled, well-timed wallop is an impactor. This will change the asteroid's speed and orbital path so that it will miss Earth. The more time we have, the smaller the punch required. If we had at least a decade's warning, we'd fly a large spacecraft near the asteroid. The small gravitational pull from the craft would be enough to draw it off its current course, just enough to miss the Earth. And if all else fails, or if time is against us, a risky approach would be to blow it up. Risky because exploding the asteroid would likely shatter it into many pieces that could hit the Earth. But why are you here? Not to defend the Earth from a possible asteroid impact, as machines will likely do that job, not humans. If you are here, it's because you're part of a much bigger adventure. We have an instinctive curiosity to explore other worlds. This led us to the moon. Today, it spurs us to cross the solar system. In our quest to find life beyond our planet, we explore worlds that we know or suspect contain water. We're very interested in the ice-covered poles of Mars and its tiny moons, Phobos and Deimos. Another great candidate for water is Ceres, the largest object in the asteroid belt. Recently, we discovered several bright spots on the surface, suggesting either ice or a dried sediment. And one of the largest bodies of water is on Europa, one of Jupiter's moons. Vast frozen oceans and lakes are thought to exist under a deep layer of ice. Who knows what life exists here? Although a journey to Europa could take less than 3 years, and as short as 7 months to get to Mars, right now, it's a one-way ticket. We couldn't make it home. Launching astronauts into space consumes tons of fuel, as Earth's gravity is pulling us back down to the surface. Returning home from a distant world requires more fuel than we can carry. What's the solution? One idea is a refueling station in space. But to have a station out here, big or small, we would have to get fuel off the Earth in the first place. Or would we? Not if we get our fuel from asteroids. Inside some asteroids is a wealth of useful resources, such as hydrated minerals. From these, we could extract water molecules and separate them chemically to create hydrogen fuel. We can also extract oxygen to breathe and water to drink. Robots will go before humans. They'll take a closer look at the asteroid's composition, map its gravity, and locate and set up a safe landing site for astronauts that follow. Back home, we will be preparing for our most challenging human expedition ever. The moon is the farthest humans have ventured into space. Its romantic image is very deceiving. With no air to breathe and extreme temperatures, it's a very hostile place. Yet we have ventured here several times. We've also ventured to low Earth orbit, and what an experience it is to take a spacewalk here. At 400 kilometers above the Earth, aboard the International Space Station, small groups of astronauts live and work for months at a time. Tasks vary from conducting research in microgravity to servicing the craft. Important experiments are teaching us the effects of weightlessness on our bodies, critical to the health of astronauts on long voyages into deep space. As part of the asteroid mission team, you will likely gain invaluable experience here first. Another space training ground is much farther away, in high Earth orbit. "100 times higher than the space station, conditions are much more extreme. You'll work on satellites in need of repair or a tool. Grappling with one of these will give you valuable experience when it comes to securing yourself to a rotating asteroid with little gravity. But our target asteroid is likely to be several million kilometers away. Such a lengthy journey brings new challenges and risks.